This learning video will focus on running PT optimizations in RAM concept and then reviewing the results. After preparing tendons and profile polylines and modeling any optimization regions, you are ready to start an optimization. To start the process, click on the Optimize Tendons tool button at the top of the screen. This will kick off a series of checks that will split the tendons and profile polylines at region boundaries. If the process changes the file, the warning prompt here will be displayed on screen. After clicking OK, the Save As dialog will appear. This is your opportunity to save the file with the different file name so that you can keep the original file without the changes made during the pre-process. After saving the file, the Start Optimization dialog will appear. This dialog is where the criteria controlling the optimizations are set. Let's take a brief look at the information and settings stored in this dialog. The Optimization Regions box lists each optimization region defined in the model and the number of optimizable properties that are associated with it. If no region was defined, then a single entry with whole slab would be listed as the region name. The program limits the number of optimizable properties in any one region to 75. If the listed number of properties exceeds this value, then you will either need to add optimization regions or change some tendons or profile polylines so that they are not optimized. The trial diversity slider tells the optimizer how hard to look for the best solution. The notch on the left end represents a normal search and lowest usage cost. The notch on the right end represents the most intensive search and the highest usage cost. Usage is tracked by ACUs, and that is the Bentley standard unit for cloud consumption. Note that the rate is displayed at the top of the box, and that rate may change as the slider is moved to the right or to the left. In general, as the slider moves to the right, the rate of consumption, the total solution time, and therefore the total ACU consumption will increase. In most cases, the slider can be placed at the left end with a good chance of finding the optimal solution at the lowest cost. The Seed with Model's Current Parameters option tells the optimizer to use the current tendon and profile parameters as a starting point in the optimization. This may reduce the total number of iterations needed to complete the optimization. You might use this option if you are value engineering an existing model with a final design, or if you've completed a few manual iterations and have a good design that you want to improve. The last three options in the dialog control when the optimization is stopped. The maximum number of iterations could be used to help stop a model that is struggling to converge and is running indefinitely. Most models will converge in less than about 100 iterations, so this is not normally an issue. The last two options, number of non-improvement iterations and improvement tolerance, are related. The value of 20 for number of non-improvement iterations tells the optimizer to take the percent change between the best solution in the current iteration and the best solution found 20 iterations ago. That percent change is then compared to the improvement tolerance, and if it is less, then the optimization is stopped. Setting the improvement tolerance to a very low value would cause the optimizer to calculate a large number of iterations, which would then drive up the cost of the optimization. After reviewing and making any changes to the optimization criteria, you are ready to start an optimization. You will first need to enter a scenario name, then click OK to start the process. We recommend limiting the number of optimizable properties in any region to 50 for best results. If the number exceeds this value, then a warning like the one shown here is displayed. The number of properties in the regions in this model is just over this threshold, so I'll ignore the warning and click OK. This sends the model into the cloud and starts an initialization process. While the optimization is initializing or running, the Optimization Manager window is displayed on screen. This window shows the status of the optimization and more details of the iteration results as they are completed. If the window is closed, it can be reopened at any time using the Optimization Manager tool button at the top of the screen. While an optimization is running, no changes are permitted to the model data. However, it is possible to run the model and view results. This allows you to load trials from the running optimization without concern that they are out of sync with the model. The feature is designed to run automatically in the background. Optimizations can take several hours to complete, so typically you will either minimize your RAM concept window and then work on other engineering tasks, or you'll even open another RAM concept window and start work on another concrete floor in the same structure. We have fast forwarded here to a point after the optimization completed and will now review the information in the Optimization Manager. There are three main parts to the window: the Scenarios table, the Convergence chart, and the Trials table. The Scenario table lists each scenario that has been run in the model. The table lists each scenario by name and shows its status. The status will be displayed as running, finished, stopped, or run failure. The latter can occur if there's a server issue in the cloud and the optimization is automatically stopped. Percent improvement shows the percentage improvement of the best trial in the last iteration. No value will be shown here until the number of non-improvement iterations is reached. ACUs stands for Analytical Compute Unit, and again is the standard unit of consumption for Bentley Cloud Services. The table will display the total consumed by each scenario. ACUs are required to run an optimization, and you are entitled a given number of ACUs for each RAM Concept PT license or optioneering visa that you own. Warnings or errors will be displayed by the program when your account's ACU consumption approaches a certain percentage of the entitlement and then exceeds that limit. The Convergence chart tabulates total costs versus total ACUs consumed for the selected scenario. Three lines are plotted: a red line indicating best overall design with a failure penalty, a purple line indicating best overall design without the failure penalty, and a green line indicating best valid design. A valid design is one that has no design code failures. This particular model is not typical since there were no failures in any of the trials. This is why we don't see a red or purple line. Because of that, I'm going to jump to a different model that will show a graph that will better illustrate what you are likely to see in the optimizations that you run. In general, failures should be expected in the early iterations. So there will be a gap between the red and purple lines, which are the designs with the failure penalty and without the failure penalty. This gap will be larger as the difference between the program calculated result and the design code requirement increases. The gap will decrease as the iterations continue until all failures are eliminated. At this point, a single green line will indicate the cost of the most economical design. Note that you can use a mouse fence to zoom in on any specific region of the graph. You can then right-click to reset the zoom. Finally, the trials table at the bottom of the dialog lists all the cost information and failures for all the trials that are analyzed during the optimization process. The table includes the optimized cost, which is the sum of the PT, rebar, and stud rail material and labor costs, and also the model cost, which is the optimized cost plus the material and labor costs of concrete and formwork. Note that the values in each column can be sorted in ascending or descending order simply by clicking on the column headers. There is also an Export Scenario Data button at the top of the window that can be used to export the cost information for a scenario to a CSV file. The information in that file can then be used to create your own custom convergence chart. After the optimization is complete, you will typically click on the Load Best button. This will load the most economical design into the model. After loading this design, you can then run the calculations, review the results, and make any changes that you feel are required. The Load Selected button works in the same way and can be used to load any trial that is selected in the table. Note that you can use both options, Load Best or Load Selected, while the optimization process is still running.